Hi, I'm Leonard, and I'm going to talk about DevOps in a machine learning world. This is the kind of summary for the talk, and I really wanted to talk about machine learning because it's becoming a little bit more commonplace these days. So I think that previously it used to be niche, and now it's pretty mainstream. I'm pretty sure everyone in this room would have heard of machine learning at some point, and it's starting to make a bit of a difference. And I want to discuss some of the challenges. So we use it within the company. And I want to talk about kind of how we've brought machine learning, which has actually been around now for 40 years, into the modern age. So who am I? I'm Leonard. I'm a co-founder at Ravelin. I was the CTO of the 4 co-founders. And at the beginning, it meant I did a bit of everything. So it meant I was doing software engineering, DevOps, and recruitment. They were my 3 main jobs. And now, most of the time, I send emails and I read emails. So I'm a bit of an imposter. But that's me on Twitter, Leonard Austin. So if you want to follow me, feel free. So what does Ravelin do? The first few slides talks a little bit about Ravelin and what we do and why it's important. So basically, we do fraud detection. And there's a lot of data involved in fraud detection, and I'll go on to why that is in a second. But basically, we use machine learning, we use graph networks, and we use some rule engines, and we have industry expertise kind of working in-house to try and catch these fraudsters. We raised $2 million last year, so we're very much a startup. For those of you who like buzzwords, we're fintech, and we're also hiring, and I'll come on to the hiring bit in a bit as well. So fraud, what does that actually mean? There's lots of different people. When we talk to people, people have lots of different opinions on what fraud is. And how big of a problem is it really? So we've lost $14 billion in fraud, and it's actually growing rapidly. Who here has lost money through fraud? Okay, there's only one person, which is surprising. I thought no one would have done. No one sees this as a problem, basically. So where does this money go? 14 billion is a big number. So it's the merchants that actually pay for the fraud. So when someone uses a stolen credit card online and the rightful owner goes, I want my money back, the credit card companies go, yep, brilliant. And we've got really good consumer protection laws here. So generally speaking, fraud doesn't affect you guys. But I'm pretty sure that around 90% of you guys have had your card declined for whatever reason. Whether you've gone overseas or you've just tried to buy something in Sainsbury's and the card doesn't work. And that's basically because the fraudsters. The banks think that a fraudulent guy is using your card. So it's a difficult problem for those guys. The other thing is that chip and PIN came in not that long ago, and basically fraud in the real world completely stopped. It died. Like, I think less than 1% of all fraud now is committed in the physical world, in Europe anyway. But it all moved online. Literally, the fraudsters went, shit, I'd rather get the stuff delivered to me than having to go and pick it up and get CCTV'd on the rest of it. The US haven't moved to chip and PIN yet. They've just introduced chip cards, but they haven't introduced the PIN part. So later this year or next year, they're going to introduce the PIN part, and then we're going to see fraud just skyrocket online. So why is it so hard? So I stole this slide from one of my colleagues, but this is a slide of M's and 1 N. So this is a little bit like the real world of trying to catch fraudsters. Don't worry, the slide's up for the next 4 slides has this picture on it, so you guys can slowly go through and spot it. So here's the thing. If you're in a startup world, what you want to do is you really want to encourage people to come and use your application, add their credit card, and start buying stuff. And that's really good. But most startups have a problem where most people will sign up and not use the service. Fraudsters, on the other hand, they sign up and they use the card and they buy loads of stuff. And they look like an amazing customer. They look like a lighthouse customer and like someone who's really going to use your product. But then 3 months later, you found out, shit, that's a fraudster, and you've just lost all your money. So it's a bit of a problem. The cost of one fraudster, depending on your margin, if you're in a marketplace business, can wipe out 100 real transactions. So it's a big problem. So how do you stop the fraudsters? So it's really good that we live in an age where we have cutting-edge banks, and MasterCard and Visa and Amex use really good stuff these days. So they got together and they came up with a solution to solve this problem. And this solution is phenomenal, and it's called 3D Secure. And this thing here This thing here is brilliant. 100% of you guys would have come across this page. And it's awesome, because it does stop the fraudsters. Fraudsters don't know your password. They have your card details. You can buy it online for about $1, 50 cents. Here's the hilarious thing. You can go on the dark web. You can buy a credit card number. And the guy you buy it off will give you a money-back guarantee if it doesn't work. How amazing is that? So no more fraud. Brilliant. You have caught the fraudster. So what you've done is you've caught that guy there. Job done. The problem is conversion rate. So when you turn on 3D Secure, you typically prevent 20% to 25% of your customers going through the checkout process. It's a huge drop in conversion. And it's to catch this one guy here. And if you're on mobile, we have clients that have had drops of conversion rates of 50%. 50%, that's a huge number. So that's a little bit of history. That's also a little bit about banks and how fraud works. Obviously, Mondo are completely different. These guys are using the best stuff. They're never going to have 3D Secure unless they're made to. So what's our stack? So our stack's very similar to the Mondo guys. We use Go. I used to work at Halo. We did a lot of microservices there. Some of the guys at Mondo did as well. We have Python. The only reason we're using Python is because of machine learning. So Python is really mature in its machine learning libraries. Go isn't so. There's one really good repository, but it's in its infancy. We're on AWS, as most of you guys are. Get on the Go bandwagon, by the way. If any one of you guys not using Go or haven't learned Go, really jump on that bandwagon. It compiles to almost a static binary. You can just put it somewhere and run it. I mean, there's no packages, there's no gzipping. You just start it. It's a really, really nice product. So we obviously use microservices. We're a hip, cool startup. If you don't have that word in your manifesto, then investors aren't going to invest in you. And we have a lot of databases. So we use Cassandra, Postgres, Elasticsearch, Redis. We use a graph database, which we built ourselves, and we use Zookeeper. So it's one of the reasons we do that is because we use the right tool for the right job. And I'll come on to that in a little bit as well. Queuing technologies, we use a combination of NSQ and Kinesis. And instrumentation is we use InfluxDB and Grafana. Now, I called this monitoring, but the guys at work said that I shouldn't use the word monitoring in front of DevOps people because you guys will think it means putting New Relic on your server and just seeing the CPU stats or collect D. Instrumentation is something that's really important. You can see how your application is doing, how many requests are going wrong. And when we have any problems at all, we go straight to Grafana, and we can pinpoint exactly which service is misbehaving. So I highly recommend that. The last buzzword I'm going to put on here is Docker. I don't like Docker. Now, I know it's controversial. Lots of people like Docker, and going forward, it'll be wonderful. We use it for local development, and it's brilliant for that. But otherwise, I'm not a huge fan. So we want to do things the right way. And like I said, machine learning's been around a while, and they're a bit old school. And what we're doing is we're trying to bring them into the future. So these are kind of the things that I personally believe in. So Terraform, I can't remember the name of the last speaker, but I completely agree. Terraform is phenomenal. We use CloudFormation. Our production stack got in an unrecoverable state. And what that means is that you have to contact AWS support. And you can't update your stack until they get back to you. And 7 days later, they got back to us. And they said, okay, we have to escalate this to extra support. They did. And then they came back and went fixed. And then we tried it again, and it got back into the unrecoverable state. I think CloudFormation was a nice idea, but implemented really badly. Terraform's a nice idea, but implemented reasonably well. So I'd 100% say switch to that. 100% automation, love to do that. I want to be able to go in and bring up a new environment at the click of a button. We want to horizontally scale. We're going to grow beyond our wildest dreams. We're going to have billions of customers, so we need to be able to scale horizontally. Security. So I take a slightly different approach to Simon. I don't think anyone should be able to SSH into a box. I fundamentally think that if you have a production system and someone SSHs into your box, alarm bells should start ringing. No one should have access, full stop. We live in a day and age where you can have centralized monitoring. You can have centralized logging, all of that stuff. You don't need to have SSH access. In reality, everyone in the company has SSH access, and they still log in on a daily basis. But the dream's there. The dream is there. So the last thing I'm going to say before I really talk about machine learning problems is a little bit about this. So this is not a server. It's a puppy. Don't confuse the two. And the reason you shouldn't confuse the two is because a puppy is something you should care about and love, and you should name. A server is not that. It's not a pet. So a server is cattle. If your server misbehaves or microservice misbehaves, just terminate it, and a new one will come up. And if you haven't built, your system to work with just terminating stuff, then you need to rejig it so it really works that way. A real story. Last Wednesday, AWS decided to kill one of our servers at random. No reason, just disappeared. And it was a Zookeeper node. And we have one Zookeeper node in each AZ, so we have 3 AZs. And everyone who works with Zookeeper knows that Zookeeper's fine as long as you've got quorum. So 2 out of the 3 servers were fine. But if we lost another server for whatever reason, then we'd be screwed. Anyway, so in a little auto-scaling group, a new one popped up, and it just rejoined the cluster. And everything worked really beautifully. And we couldn't have done that unless we prepared for fully automated systems. So it's a really important lesson that we learned. Now, I'm not saying that we weren't involved at all. I was shitting myself. And 2 other engineers at the time were just looking at the screen, hoping that everything worked. But it worked, so that's a nice thing. Machine learning challenges. So the main thing is really about the life cycle. So there's 3 steps in machine learning. You've got to explore the data, you've got to train on the data, and then you've got to deploy the models. So the first one is all about explore. And when we're talking about large amounts of data, we talk about data warehousing. And I want to just go through what data warehousing is. Has everyone here heard of the phrase data warehousing? Yeah? OK. I'll go through this reasonably quickly then. So most of the time you have databases for operational stuff, services that need real-time access. You get the information in, you get it out, done. What we also need is we need another database that data scientists can work on, and they can just run queries at it, and they're long-running queries, use loads of resources, don't have index on it, returns a result 24 hours later. What you don't want to do is you don't want to have the same operational database as the data science database. You don't want to affect your production load. So what do we use it for? We use our data warehouse for exploratory work. So it means the data scientist goes, I really think this feature is going to be good for detecting fraud. And it will be some weird one about an email address and a country and a postcode and all these things. Anyway, he can run a stupidly long query. You should see the queries. They're pages long. And it won't affect anything. And that's what a data warehouse is for. In terms of data, I would say anything more than a terabyte of data, you probably want to be putting it into a data warehouse. When I talk about data warehousing, I would actually say probably anything above 100 gig might be worth moving into a data warehouse. So what I want to do is I want to walk you through where we've come with data warehousing. So 15 to 20 years ago, you had to have $10 million to have a data warehouse. And you had to go to IBM or Oracle or Microsoft. And I know some of you guys probably still go to those guys. You're richer than I am. So, and this is per year. So you had to pay this as a license fee, and they would manage it and all the rest of it. And then 10 years later, the price came down, and it's 1 million. So this is when you had MPP, for those who can remember. IBM, Oracle, Microsoft are still in the game, but now you've got Teradata, Vertica, Greenplum, and a load of other guys. And it's coming down. And this is what I'm calling 1.5, because it's not a really big shift. It just happens that they've been able to reduce the cost. And then you get the open source community coming out. And Google wrote a paper about MapReduce. Yahoo decided to implement it, called it Hadoop. And what you've done is you've effectively given away this software for free now. So it's open source. The only cost is the servers, the consultants, and the devs. And consultants are really expensive, especially contractors. And if there's any Hadoop contractors in here, you guys probably charge, what, 1,000, 2,000, 3,000 pounds a day? It's crazy fees. So that's what I would call V2. So there's been a step change, and this is V3. And V3 really, I think, personally, has revolutionized this whole thing. And it means that 200K a year now costs $500 a year. And it's one specific technology that I'm advocating for, and it's BigQuery. So BigQuery is a Google product. It's completely managed, and I have been blown away by how good this product is. So I just want to talk about the cost of it, because it costs $5 per terabyte of data you store in BigQuery. I mean, that's per month, but that's still insane. That's a crazy amount of money to be charging. I think that might be the same price as S3, but it's a database. So I think it's really good. And we don't just stream all of our clients' data into BigQuery. We stream all our tracing into BigQuery. All of our logs go in there. Everything goes in there. I think last month we put 35 terabytes of data into BigQuery. It just worked. It was just really good. So we love BigQuery. It's really cheap. There are a few gotchas. There is not a single index on BigQuery whatsoever. So not even the ID, the primary key, is indexed. So what that means is when you write to it, it distributes it across loads and loads of different volumes, across loads of machines. And when you want to access the data, if you want one key back, you have to range over the entire data set on all of these processes. On all of the machines that you've got. But it means that you can add a column without any worry at all. There's no schema migration. You just suddenly add a column, boom, you've got it, it's done. All the previous ones are null. The other thing is that if you don't query the data, then you don't pay. You pay the $5 a month, but effectively that's it. So it means that every time you query, you pay a small fee. And it's 5 cents per terabyte that you range over. So there's a little bit there. You don't have to pay for resources. So it's a mind shift change, but you do have to pay when you query. So it's a little bit different there. There's also 2 other restrictions. So the first thing is you can't update. It's append only. So you write the data and it's done. And I said no indexes, which is interesting because it's a curse and a blessing at the same time. So data scientists can go in and write their fancy queries and connect and join everything up, and it will all work fine. And to range over 35 terabytes of data takes 10 seconds. But to range over 100 megabytes of data also takes 10 seconds, because they parallelize all the tasks as much as possible and as much as you need. But it means that if I want to get customer ID equals 7, I can't do that. I have to go through all of the data just to get that one customer row. So it's not really suitable for some stuff. I put data flow there. Data flow is part of the BigQuery family in terms of big data in Google. What it means is I can get a huge table, terabytes of data. I can run a query, and I can pull it out, and I can pop it onto PubSub, which is their queuing system, and I can apply data flow on top of it. And data flow is basically joining over streaming data. And for those of you who have worked with Spark previously, it's a bit like that, but it has windowing functions, and it can do entire. It's a phenomenal product. And if you really want to look at data warehousing, I'd highly suggest you have a look at that. Oh, and it doesn't require any of your time either. So you don't have to manage it. You're DevOps, you don't need to manage it. I probably need to mention Redshift at this point as well. So Redshift is something that I've used in a previous company, and it's expensive as hell, but it is Postgres, and it just does work, but it's just really expensive. So the stack's changed a bit now. So now we have AWS and Google Cloud Platform. So we're actually on 2 different cloud providers. And it goes back to our original philosophy of the best tool for the job. And those are the best tools for the job. One thing I would say about Google is we have a really good account manager. And I've known people who've tried Google and didn't have a great account manager, and they've been a bit disappointed. So if there's anyone here who's seriously looking at it, then let me know, and I'll ping my account manager's details to you. Second one's resource on demand. So this is a little bit of an easier one. With machine learning, to actually run the analysis is really cheap and really easy. You can put that on a micro instance, and probably not a large instance, you'd probably be okay. But to train, it's really expensive. And you need big, chunky computers, otherwise it takes ages. And one of the problems you're going to find is getting these data scientists who've been around and done analysis on their laptops and on their desktops, who want big hard drives and big RAM locally so they can work on the data, moving them to the cloud. It's a big challenge, and we managed to get this guy called Stephen, who works with us, onto the cloud. And he's super happy. He was like, what? I have 32 cores and 208 gigs of RAM. Things are 10 times quicker. So a bit of upfront work, getting them to move to the cloud. The other thing is that generally speaking, you don't usually have too much data. You can usually fit it in 200 gigs of RAM. When I talked about terabytes of data previously, typically that's your raw data set. And when you run queries, you pull it down and you reduce it and you refine it. And then you can typically get it down to less than 200 gigabytes. And if you can't, then you can sample instead. And you'll typically find that the model's performance that you're training on isn't that different. But either way, this is getting bigger and bigger every day. So I think that you can try and do it on one machine, and it will be the single point of success. It's not gonna fall over. Sorry. One other thing about this is when they have all their tools on the machine, we can kill that instance on Google. And when we start the instance the next day, the volume that was on it previously automatically gets attached to the new box. So its state is completely saved at all. We just don't pay any of the costs.
There's 5 minutes left.
Yep, cool.
To include questions too.
Okay, yep, no problem. I'll rush through this. Deploying is really easy. You train, you pickle them, you put them S3, you pull them down. It's literally the easiest thing. So the last thing is GPUs. So this is specifically for deep learning. AWS have GPU machines, but they're really expensive. There's no virtualization. So with AWS at the moment, you have boxes and you can virtualize the cores. So that's why you can get 32 cores. But you can't virtualize GPUs. So the recommendation here is build your own, which is funny because no one's doing that anymore. But actually, if you want to do deep learning, then you should just go out to the normal, I don't know where you buy them from nowadays, Maplins, and you buy a big graphics card, and you build it yourself in your office. But really ask the question, do you need GPUs? Because it's only really good for speech, video, and images. So in summary, data warehousing, BigQuery, data flow, and on demand, you want one machine because clustering is really expensive in terms of time and money. And you can use persistent volumes on Google Cloud Compute. And finally, the reason I'm actually here isn't to share information. It's because we're hiring. So if there's anyone who's looking to join a startup, we're hiring for all these positions: DevOps, data scientists, software engineers, and a product owner. So thanks for listening. Is there any questions? Yep.
So you mentioned the BigQuery, that there is no indexes and that searching for small amount of data or large amount of data actually costs you the same amount of time.
Yeah.
And I assume your amount of data is only growing. So this amount of time will only grow.
Yep.
To cheat that, have you thought or are you doing any kind of data sharding?
So absolutely. One of the recommendations they do is you shard your data by time. So that way, each of the tables have a timestamp, and actually their UI is built for that. So you select the table name, and you have a list of all the dates. So you only have to range over a particular time period. And we do go one step further as well. We compact all of our data on a regular basis and build another BigQuery table with the last year's worth of data. So it's really up to date, and it's a lot quicker and a lot smaller. So yeah, absolutely.
Cross-border, multinational financial data security.
Mm-hmm. So everything's hosted in the EU. So with regards to the safe harbor agreement, it doesn't really apply because we don't ship anything over to the US. Security, we take it really seriously. We have two-factor on everything. We have VPNs. Like I said, we have alarm bells that go off whenever someone logs into production. So it's something we take really seriously. And we've spoken to the Google guys. And obviously, everyone here is pretty clued up with the Amazon stuff. But the Google guys are equally, they care as much as well. And they have all the same PCI and ISO standards. So
when you shift to American customers, how will you deal with that?
We're probably going to shard the data. So we'll probably house the US data in the US and keep the European data here. It's really important for a lot of our customers because they're quite large customers.
So guys,
Sorry, yep.
there's the pub. There's always the